Today we're starting 6.7, solving equations and modeling. I should change the wording to what happened, change this to what happened this weekend. The earthquake that hit Japan. What? That's what happened. Is the earthquake was in the middle of the ocean, and that's what caused the tsunami that came through. Because it goes, the earthquake or the tsunami goes both directions. You have to think, if you throw something into a pool, the splash goes both ways. Except for Japan was closer, so that's why it hit most. Earthquake that hit Japan this weekend was 8.9 on the Richter scale. M stands for magnitude. The amount of energy, E, in ergs released by an earthquake can be modeled as M equals 2/3 log of E divided by 10 to the 11.8. The magnitude of the earthquake was 8.9. So I have 8.9 equals 2/3 log of E over 10 to the 11.8. What would be my first step? Multiply by 3/2, or divide by 2/3. 8.9 times by 3/2.
Is that 11E? It looks like 8.
8. So I have 13.35 equals log of E over 10 to the 11.8. Yes? What do you mean? Use like 3 decimal places. Yeah. Now I have a log. What gets rid of a logarithm? 10 to the gets rid of. So if I take 10 to the to both sides, so if I have 10 to the 13.35 equals 10 to the log of E over 10 to the 11.8. What happens when I take a 10 to the and a log? Those cancel out. So I have 10 to the 13.35 equals E over 10 to the 11.8. How do I solve for E? What do? Multiply by 10 to 11.8. Multiply to 10 to the 11.8. What do I do when I multiply? I add exponents. So I'm going to take 11.8 plus 13.35. So I have 10 to the 25.15 is how much energy was released. If I want to find out how much energy exactly, 10 to the 25.15. 1.41 times 10 20 to the 25th in scientific notation. So it's 141 with 23 more zeros on the end. It's a lot of energy released. That is your final answer, the 1.41 times 10 to the 25th. The 11.8 and the 13.35. That's how I get the 25. So 1, 4, 1, 2, 3, 4, 5, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Well, I rounded, so there wouldn't be zeros all in here. This is how much energy was released in ergs. There's probably a multiplier, yes. I don't know how I'd say it exactly. I don't know how to say this. Key. That means times 10 to the, yeah. All right? We have log of x plus log of x minus 3 equals 1. We want to find out what x is. What can be my first step? What do you mean by multiplying? So you're saying multiply these two, right? So it says log of x times x minus 3 equals 1. So all you did was combine the two because it was the plus and they had the same base. What base do I really have? I have base 10. Now, how do I get rid of the log? 10 to the. So if I take 10 to the, it cancels it out. X times x minus 3 equals 10 to the first. With, mean like I did in the last one? I'm cutting out that little step. You should know. It saves you a lot of writing, too. But I am going 10 to the log x minus 3 equals 10 to the 1. That's what I'm really doing. Yes. Because if I subtract the 1 over, I can't do anything with it. But it doesn't have a log base 10. That's why it doesn't go in with it. This is where you have to be careful. Things that are not logarithms cannot be just thrown in with them. If this was log base 10, I can do something. What do I do here? Distribute and get x squared equals 10. What should I try to do? Try to factor. What do I have to do first, though? X squared minus 3x minus 10 equals 0. I need to try to factor, complete the square, quadratic formula, whatever way you want to solve the quadratic. I'm going to try to factor it. X and x. One has to be plus, one has to be minus. The bigger one has to be minus. Two numbers that multiply to give me 10, negative 3. Positive 2, negative 5. My answers are negative 2 and 5. What do I have to do for any logarithm problem? Check to see if they work. Okay, negative 2. Can I put log of negative 2? No. Just to check the other one, can I take the log of 5? What's 5 minus 3? Does it work fine? The only answer really is 5. Here's this type. These are all different types. We're piecing together all this knowledge from this chapter, putting it all together. I have 4 times e to the 3x minus 5 equals 72. What should be my first step? Divide by 4. You don't want anything in front of the e, the ln, the log, whatever. Divide by 4. So I have e to the 3x minus 5 equals 18. What do I need to do here? Not exponential. Take the natural log. Why am I going to take the natural log? Natural logs and e's are opposite to one another. So if I take the ln of both sides, the ln gets rid of the e, and I'm left with 3x minus 5 equals the ln of 18. I can take the ln here, or I can do it later. Austin. ln 18 gives me that number. The reason why, if I put in the calculator ln e3, put this in, whatever you have in your calculator for x, that's what number it throws in there. So whatever your calculator has as x, that's the number it throws in. That's why everyone in this classroom could do the problem, type it in with that x, and get different answers. Yeah, some of them are zeros. I'd to do x stores 5. So that means every, whoops, I hit it backwards. 5 stores into x. That puts 5 in x. So now whenever I type x, I get 5. All right. ln of 18. 2.89, so 3x minus 5 equals 2.89. Now I need to add 5 over. 3x equals 7.89. Divide by 3. .63. That's your answer. And I can check, I can put in 2.63, I don't have to worry, I'm good. Yeah, you know how to store stuff in the x, but that only puts a certain number. It doesn't find x.
That's what I'm saying. I'm talking about the check how it works.
Yeah, you can do that. You can, or say I have a function of x squared minus 5x plus 2, and you know that x is 5. I can go put 5 into x, which I already did, because x is 5. And just type x squared minus 5x plus 2. X is 2. That's my answer. Oh, okay, x is negative 5, or negative 3. Negative 3 stores into x. Enter. Second enter. Second enter. My answer is 26. It saves me a lot of time from having to retype. Newton's law of cooling. Physics. An object that is hotter than its surroundings will cool down. An object that is cooler than its surroundings will warm up. Makes sense, right? If something's hotter and it's colder, they balance it out. The law of cooling is T of T, that's the temperature of the object after a certain amount of time, equals T of S. That's the temperature of its surroundings. We're assuming that the temperature always stays constant. Plus, T sub O is the initial temperature of the object. K is the constant rate of decrease. T means time. When a container of food is taken out of the refrigerator, its temperature is 34 degrees. After 1 hour, the temperature of the food is 36.5 degrees. How long does it take to reach the critical point of 40 degrees? That's when bacteria begins to grow rapidly. If the room is kept a constant 70 degrees, how long will it take? All right, I'm going to take the formula and copy it over.
I don't care. Should never said 15 years.
All right, I need to know the critical value when it hits 40 degrees. TS is the temperature of the surroundings. What is the temperature of the outside? 70. Plus, what's the temperature of the item? Oh, wait, sorry. Well, it's 36.5. There's a reason why. And we said it was 34 was the initial, 70 is the room, e to the negative k, and the time is going to be 1. Yes. That's 1 hour. I need to find out what the constant decrease is. That's what I'm trying to find out first, is what's the constant decrease.
I got a question.
Yeah.
Any of those could be an X, like a TS could be an X or something like that.
Yeah, any of these could be missing. Kara. This is S. It's the formula from before.
Why is that why is everything 2 zeros?
Right here, T sub 0, that's degrees. All right. First thing I need to do, I just went through, I did 34 minus 70, and then negative k is the exponent. My first step should be what? Subtract the 70. So 36.5 minus 70 is negative
40. No. 30, yeah. 30.
Negative 33.
negative 33.5, negative 36 e to the negative k.
How did you even get negative 30?
34 minus 70. Next step, divide by negative 36. So negative 33.5 divided by negative 36. I get 0.931 e to the negative k. I take the ln of 0.931. That gets rid of the e. Negative 0.714 equals negative k. That should be a 5, sorry. So k is, yeah, I can't read today. 0.071. So k is 0.071. Once I have the constant, now I can find out how long does it take to get to 40. Find k.
Wow.
Once I find k, then I can go and find out what t is when I know it's 40.
Stop trying to figure it out.
So I'm going to redo the problem. But this time, 40 equals 70 plus, and I already know this is negative 36.
Oh, no, okay, I got you.
And this will be negative, whoops, I need a little bit more room. E to the negative 0.071 t. Just so I had room to write it. Negative 0.071 t. We're trying to find out what t is. Yes, but the formula is negative kt. We're trying to find out how long does it take to reach the critical value. First thing I'm going to do, subtract over the 70. Negative 30 equals negative 36 e to the negative 0.071 t. Take 30 divided by 36, and I get 0.833. How do I get rid of an e? Take the ln of 0.833. I get negative 0.183. Negative 0.071 t.
So how did the whole from the first?
Right up here. I subtracted over the 70, so I get the negative 30 from. Divide by the negative 36, and I get the 0.833. Now to get rid of the e, I take the ln of both sides. ln of 0.833 is negative 0.183. The ln of e to the negative 0.071 t just gives me negative 0.71 t. So I take the negative 0.183 divided by negative 0.071. It takes 2.58 hours. So after about 2.5 hours, you're starting to reach critical temperature. So after 3 hours, bacteria is getting bad.